Lesson 35, Hypothesis Testing Procedure for Two Population Means. Example 1. The World Health Organization asserts that children who are breastfed as infants have higher IQ test scores in elementary school, on average, than children who are formula-fed. Researchers investigating this issue administered standardized IQ tests to a random sample of elementary school students. The 82 children tested who were breastfed had a mean IQ test score of 104.7 with a standard deviation of 13.6. The 118 children tested who were formula-fed had a mean IQ test score of 99.4 with a standard deviation of 15.2. Question: do the researchers have sufficient sample evidence to substantiate the World Health Organization's assertion? Well, there are two possible answers for this question. It's either yes, the researchers do have sufficient sample evidence, or no, the researchers do not. Statistically, to answer these types of questions, we need to conduct a hypothesis test procedure. This way, we can see if this idea is valid or not. Now, the World Health Organization assertion is that children who are breastfed as infants have higher IQ test scores in elementary school, on average, than children who were formula-fed. This idea can be expressed statistically by noting that the on average is referring to a mean, mu, and children who are breastfed as infants and children who are formula-fed as infants are two different populations. So we're making a comparison between mu1 and mu2. The assertion is that the children who are breastfed as infants have higher IQ test scores in elementary school, on average, than children who are formula-fed. Higher indicates a greater than mean. So here, the statistical form of this idea is that mu1 is greater than mu2, where 1 is referring to the first population, which were the children who were breastfed as infants, and 2 is referring to the second population, which were the children who were formula-fed as infants. So in this example, we'll be conducting a hypothesis testing procedure for two population means. So the following steps are followed in order to conduct the hypothesis testing procedure, starting with the stating of the hypotheses statistically. Here we have the mu1 greater than mu2, which is what the World Health Organization asserted. So if the answer is yes, there is sufficient evidence to substantiate the World Health Organization's assertion, then the data would indicate that mu1 is greater than mu2. But if the answer is the opposite, no, there's not sufficient sample evidence, then the opposite would be true. mu1 is less than or equal to mu2. Now, the mu1 less than or equal to mu2 includes the condition of equality. The condition of equality is always labeled as the HO. The opposite, without the equality, is labeled as the H1. So here, the statistical form for this hypothesis is of HO, mu1 less than or equal to mu2, versus the H1, that mu1 is greater than mu2. Next, we then identify the level of significance alpha. Here, we will use the customary alpha of 0.05. Next, to-samp t-test is the command on the TI-84 calculator that we use to calculate the p-value. But in order to calculate the p-value, we need our sample results. So looking at the sample results, we see that the 82 children tested who were breastfed, now the children who were breastfed was our first population, and the 82 children tested was the sample from that first population. So the 82 is our N1, the first sample size. And in this sample of 82 children tested, they had a mean IQ test score of 104.7. So the mean for this first sample, x bar 1, is equal to 104.7, with a standard deviation of 13.6. Thus, we know that the standard deviation for this first sample, Sx1, is equal to 13.6. Now, the 118 children tested who were formula-fed is the sample size for this second sample, because the children tested who were formula-fed were from the second population. So the sample size here for the N2 equals 118. And this second sample had a mean IQ test score of 99.4. So the mean for the second sample, x bar 2, equals 99.4. With a standard deviation of 15.2, indicates that the standard deviation for the second sample, Sx2, equals 15.2. So now we could take these sample results and use it with the 2SAMP t-test command to calculate the p-value. So on the TI-84 calculator, we would press Stat, arrow over to Tests, and then arrow down to 2SAMP t-test. Enter. Now what we have for input is statistics. So we arrow over to Stats, press Enter to select, then down arrow. We enter the statistics. X bar 1 equals 104.7, enter. Sx1 equals 13.6, enter. N1 equals 82, enter. X bar 2 equals 99.4, enter. Sx2 equals 15.2, enter. And N2 equals 118, enter. Now the H1 contains the greater than inequality, so we need to arrow over to the greater than symbol and then press Enter to select to match the calculator with H1. Down arrow. Pooled is no because we are not using the pooled approach. Down arrow to calculate, we press Enter to calculate the results, which include the p-value. So here the p-value, a probability which we can round to 3 places after the decimal, works out to be 0.005. So now that we have our p-value calculated, we can reach our decision. Since the p-value of 0.005 is 0.05 or less, the decision is to reject HO. And when we reject HO, we have sufficient sample evidence to indicate that HO is not valid. And if HO is not valid, the opposite idea, H1, is valid. So in this case, we do have sufficient sample evidence to indicate that mu1 is greater than mu2, which is what the World Health Organization asserted. So therefore, the World Health Organization's assertion is valid. So now, based on our results of this hypothesis testing procedure, we can give the following conclusion. Therefore, the researchers do have sufficient sample evidence to substantiate the World Health Organization's assertion that children who are breastfed as infants have higher IQ test scores in elementary school, on average, than children who are formula-fed.